happy today to present for you the high pressure spray technology using SNVI metal alloy to manufacture rapid wax injection mold. Have been developed by my professor, Dr. Mao, in the same department. Upgrade my presentation that the SNVI metal alloy with the low melting point and the small thermal shrink was used as the spraying material. We apply an electrical heated device and the high pressure hose pump to melting SNVI alloy went through a small spray nozzle and atomize it into the semi-melting minor particle. The atomizer particle happens deposit and integrated on the surface of intermediate silicon rubber mold, which is made from the rapid prototyping RP system and are successfully used to manufacture rapid wax injection mold. In general, to develop the incremental part, we use the rapid prototyping process or the CNC. The rapid prototyping is divided into two parts: the silicon mold or the metal resin mold. The CNC is the CNC machining or the EDM. But the advantage of the rapid prototyping that the process time is very short, but actually the advantage is that the accuracy is very bad compared to the CNC. And this is the question: how can we lose this problem that we use the rapid prototyping and have a good accuracy? The principle of our research that the material powder or wire heating and melting, sending the gas with a high speed impact attached to the surface or workpiece surface, accumulation, the formation of thickness or coating solidification. Our objective is to change the surface property, impact resistant and wear. And here in this picture we have appearance and of the structure of our system. It's divided to 5 parts. First, the controller to control the temperature, and second is the supply. Here is our spray gun and the pressure, and finally is the supply. We put our material, and in the end is the operation to control the platform who we put about our rubber mold. Now is the technical process and the apparatus of the thermal spray mold molding system. This is divided in 3 parts. First is the filter system, and it's here. Here we put our liquid. For us now is SNVI metal, the electrothermal tank, and the second part is here. Is the user part device, and the last part, the spraying gun system, is here. The fundamental process includes fusing low melting point alloy powder, atomizing it, and depositing it into the surface of the substrate here. And the table shows us the spray condition. We have 210 for the electrothermal tank, and for the spray gun, 200 for the 200 degree for the pressure of the post pump, and the spray nozzle diameter is 0.2794 millimeter. Our spray angle is 60 grad, and the spray distance is 450 millimeter. Now is the process show us how is the thermal spray mold tolling system. First, we need to make the 3D solid mold. After the rapid prototyping is manufactured by the 3D rapid prototyping machine, the silicon rubber mold. The silicon rubber mold is made by inverting from the master pattern of rapid prototype sample. Then we use the silicon mold like a substrate for our high pressure thermal spray system. And in the end, we use the aluminium epoxy powder mixture are caused to make the back up of the spray layer. And finally, the spray metal shell is separated from the silicon rubber mold to obtain the desired pattern. Result and discussion, the microstructure and fast character. In this picture, we can see the micromorphology of atomized SN-BI alloy particle by SEN. And that shows us that the particle obtained from the spray gun with the air pressure of 96 kilopascal and spray distance of 450 millimeter. It is clear that the sharp of optimized particle diameter vary from 2 to 10 micrometer because our picture is just 20 micrometer. And here we have the micrograph of spray coating surface deposited from SN-BI alloy particle and energy dispersive X-ray spectrum by EDS by SEN. And the component analysis by EDS. It is clear that SN-BI alloy exhibited a uniform distribution here of SN and BI spice due to the high velocity of spraying particle, but the biggest porosity of the mold surface is smaller than 1 millimeter, then the picture is just 7 micrometer. So the biggest porosity of the mold surface is smaller than 1 micrometer. And here we can see in the table the component of our surface for SN and BI. Here for SN is 65.06 and atomic is 69.20, and for BI is 3.94 and 30.18. And for more appearances, the picture here, our surface, and here is the spray format phase and mapping analysis of component SN and BI alloy by SEN. Here is the picture show us the SN part and the BN part. This is just for make more clear idea for the people. This picture is the cross section of spray coating layer, and it's clear to see here that the layer structure of spray coating is evident sandwich, and the texture is very compact. And our picture is 300 micrometer. And here is the surface. We will come now to analyze the surface roundness. And here is the surface roundness specimen. A is for the standard test specimen. B is for the spray coating specimen. Here is the evolution of the RI and RMAX. Like here, A is for the standard test specimen, and B is the spray coating specimen. And as shown, the RI and RMAX values were 6.726 micrometer and 25 micrometer for the standard test specimen, and 700.024 micrometer and 31.6 micrometer for the coating layer. The inaccuracy error value of RI and RMAX between the surface pattern of layer and standard test specimen are just 0.303 micrometer and 6 for RA and 6.5 micrometer for RMAX. And thus show us that the new high pressure spray deposition system can produce a good surface quantity and duplicated mold. And here, for an example for our process, is the golf bat. EA is the 3D model that, how we said before, we make it by rapid prototyping machine. And after we make the 3D silicon rubber, and now here is the spray coating mold. And as the picture show us the result, show that the wax pattern manufactured by this pressure spray technology has a good precision and surface quality. Moreover, pattern and the surface of Fermi die can be duplicated exactly by this study. And in the end, the conclusion that this process spray tolling the bar in this study is a new kind of manufacturing process which can shock the manufacturer